So hi guys, welcome back to the Ribe. Again, I'm Engineer HB and we're going to answer these past board exam problems for the topic of Chapter 8 which is springs. So still andito pa rin tayo sa machine design. So kung nakikita niyo meron tayong part 1 and of course meron tayong next part which is part 2. I'm going to divide this topic of springs into two parts which is obviously part 1 and part 2. Kasi medyo maraming formula sa spring pero try nating ano siya, ang tawag doon, i-cut ng short. Kumbaga ano yung mahalaga and ano yung kadalasang lumalabas sa board exam. So we're going to start this one or this chapter. Pero bago yon, usually nagko-conduct ako ng formula review o formula recap kung ano gagamitin mga formulas sa pag-answer ng mga problems later. So let us start doing this. So we have a profile of spring here. So itong nasa rectangle na picture. So meron tayong tatlong diameter. Ito yan. So ano-ano siya? So CDO, of course, we have a cross-sectional area, no? Or yung view nung pinaka-circle ng spring kapag hinarap mo sa iyo. So parang yan yun, parang nakaharap sa yung spring. So meron siyang DO, yung pinakalabas niya which is your major diameter or outside diameter. And yung DM which is mean diameter or your average diameter. So that's why yung linya ng DM ay nandito sa gitna. Yan. And of course, this W is yung parang kapal siya nung circle, pero siya yung nagsisilbing wire diameter. Kasi parang ito siya yung magiging pinakabilog ng mismong mga wires mo. So, yan yung wire diameter. Okay. So, kung makikita nyo sa diagram, so merong kahit panong konting formula so that we are going to see. So, we may say that the outside diameter is equal to mean diameter plus wire diameter. So, Engineer HB, bakit hindi outside diameter is equal to mean diameter plus twice nung thickness? Kasi twice nung thickness or twice nung wire diameter. Kasi nga dalawa siya, 'di ba? Why? Bakit? Kasi hindi naman inside diameter si DM but average diameter. So, kung ito si DM, of course, meron kang dW over 2 rito. So, palitan ko ng red ball pen. So, parang lang nagkaroon ng ano dito. Ayan, dW over 2. Tapos may dW over 2 ka pa dyan. So, times mo yan dalawa, that's why magiging isang buong dW at isang DM. So, you have your outside diameter there. So, okay, so proceed tayo. So, ano-ano pa yung mga letters na makikita natin? So, we have the P, small p, para siyang pitch, parang parehas siya sa thread, no? Yung mga distance ng kada adjacent parts. And we have this sign na lambda, that's the lead angle, meron siyang formula later. And of course, this letter F is the axial load of the spring o yung load na sinasalo ng spring mo. Okay, so proceed tayo sa stresses. We have two stresses here, which is the direct shear stress and the torsional shear stress. Torsional shear stress. So, ano nga ba yung direct shear stress? So, direct shear stress, we all know that is equivalent to just a simple force over area. So, kung may sinalo si spring na force or axial load, so ang magsasuffer dyan is itong wire diameter mo. That's why it is force over area, and your area is, of course, ang area ng circle basically is pi over 4 d squared, and yung diameter mo doon is your wire diameter. So paano naman si torsional shear stress? So as you can see, we have a torque here. We all know that torque is basically force times radius, and radius is equal to diameter over 2. So that was force times diameter over 2, and yung diameter dyan is your mean diameter naman. So kung ang apektado ng direct shear stress is sa wire diameter, ang apektado naman ng torsional shear stress is your mean diameter. So we all know that the shaft torsional shear stress is equal to 16T over pi d cubed. So sa usapang spring naman, ang apektado ng torsional shear stress is yung mean diameter mo. So just replace this diameter by dm. So you have your 16T over pi dm cubed. So bakit ko nga ba diniscuss itong dalawang uri ng stresses na ito na naka-apekto sa spring? So as you can see, we have the total shear stress here of formula 8kfc over 5 pi d by squared. So nakakagutom na. So madali lang naman tandaan. So ano yung formula na ito? Ito yung total shear stress. So ano si total shear stress? Total shear stress is the combination of these two stresses, the direct shear stress and the torsional shear stress. So kapag pinag-plus mo yan and you're going to simplify it, so makukuha mo itong total shear stress na ito. Ang nangyari kasi sa machine design natin dati, alam natin yung formula na ito, pero hindi natin alam kung saan ang pinagmulan. So ang shear stress ng spring ay nagmula sa direct shear and torsional shear stress. At na-simplify yon yung formula na yun. So siguro mga pag di na busy, I'm going to derive this formula. Pero meron na akong na-derive dati pero typewritten, hindi siya video. So just search on my page on how we arrive on this. So this is the total shear stress. So madaling tandaan, 8 KFC. Tapos may pi ka pang kakainin at may d squared ka pa sa ilalim. So bahala ka na paano mo tatandaan itong d squared sa ilalim. And your d squared, yung diameter na tinutukoy doon is wire diameter. Okay, so ano naman si isa-isay nating letters na ito. Of course, si F, siya load. Itong si DW is wire diameter. So ano naman si K at C? So si C is the what you call spring index. At si spring index ay may formula na ratio ng mean diameter over wire diameter. So how about si K? So si K naman is what you so-called the Walls factor. Okay, parang ano siya, kung natatandaan niyo yung mga stress racer, parang ganon. Yung sa mga early chapters ng machine design, yung parang K, MC over I. So parang siya rin yung nakaka-apekto, no, nagre-raise ng stress. So that's why it's so-called Walls factor. And it has also an equivalent of the product of two more factor. And what is that? That was the Kc times Ks. So ano yung Kc? That was the factor for curvature of coil. So medyo pinapasok na natin design considerations, no? Pero marahil lalabas din to sa board. So isang review na lang din. So kung may Kc, so meron din Ks. And what is that Ks? So that Ks is the factor for direct shear naman. Okay, so merong formula si Walls factor and that is familiar na tayo dito way back on the strength of materials, pero magkakaroon lang din tayong konting review that Walls factor or represented by small k is equal to 4c minus 1 over 4c minus 4 plus 0.615 over c. So kayo nang bahala mag-mnemonics dyan kung paano nyo tatandaan. And of course, yung letter C dyan, laging given, which is the spring index and has a ratio again of mean diameter over wire diameter. So kung may Walls factor ka na at hinahanap si factor for curvature of coil, maaaring mamanap si Kc by computing for this K of having this formula and computing of Ks having this formula of 1 plus 1 over 2C. So that was an easy compared to this K. So kapag tinanong si Kc, just divide yung K, just divide si Ks sa K kasi pareha silang may formula. Okay? So how about this last KB? Si KB ay wala dito. So minsan given si Bergstrasser factor at hinahanap yung spring index which is letter C. Represented by letter C. So si Bergstrasser factor is another factor, the same as Walls. Yung nga lang syempre may bukod siyang formula. And syempre hindi siya involved sa Walls factor kasi ang involved sa Walls factor is Kc and Ks. And this is another thing, Bergstrasser factor, baka sakaling lumabas. And it is equivalent to 4c plus 2 over 4c minus 3. Okay. So this, wala tayong formula dito pero this is the diagram of the shear stresses on wire and coil. Ibig sabihin, ito yung apat na types ng or apat na conditions na makikita mo kung paano yung stress nakakaapekto dun sa diameter, no, or dun sa spring. Okay, so meron tayo ditong circle or yung parang kaharap mo yung spring, in front view. So kapag pure torsional loading, ito yung distribution ng stress. So parang sa torsion lang ng shaft, di ba? Yan. So how about direct shear loading? Kapag direct shear naman, ganyan siya. Okay? Ganyan yung distribution ng load. And how about this third condition? So we have a torsional and direct shear with no curvature effect. So as you can see, kapag pinag-plus mo si 1 and 2, so makikita mo yung apektado niyang area, which is ito. Kasi nga, kapag number 1 lang apektado, ito lang yung drawing. At kapag pinagsama mo yung 2, so syempre mag-a-adjust yan somewhere at ito yun. So that was the distribution given this condition. And of course, number 4, ang pinagkaiba naman ng 3 sa 4, itong 3 no curvature effect, itong 4 ay may curvature effect. Pero yung distribution niya is the same, pero yung drawing, pero of course, it is a curve na. Hindi na siya straight line. Yan. Okay, that's why binakante ko talaga yung drawing na yan in order for us to see the diagram or the distribution with a comparison of with and without curvature effect. Okay? So we have the spring deformation. So kung meron tayong stress kanina, meron din tayong deformation, of course, and that has an equivalent of 8fc cube nc over gdw. So introduce natin yung bagong letter which is nc, that corresponds to the number of coils. So yan parang ganyan. Yan, parang ganyan. Parang ganyan, madami, di ba? So that was the number of coils. So and of course yung walang kamatayang g, no? That was the modulus of rigidity. Bakit damay yan si modulus of rigidity? Of course, kung may torque or torsion na nangyari, meron ding damay na angle of twist dyan. So, si deformation ay na-derive from this formula. So, saka na natin papakita yan. Mahalaga, we have this formula of 8fc cube nc over gdw. Okay, so ikaw na magkabisa niyan. So, ayan. So, we have this spring deformation. Of course, this original length is compressed to this size by the axial force. And of course, yung napiping distansya dun sa original hanggang sa dito, sa apektado, is itong spring deformation na to and has this formula. 8fc cube nc over gdw again. And how about this spring lengths? So, kung meron tayong free length dyan, kumbaga, ayan, yung spring, ilapag mo sa sahig or sa fixed area at may dumagan na force, kagaya dito. So, of course, makokompress siya ng ganitong deformation. And syempre, yung length nung napisa is, ito yung tinatawag na CL, which is your compressed length. Again, free length, yung original length mo, kapag napisa by force F, yung length na napisa is your CL, compressed length. And this third scenario naman is, ayan, napisa ulit siya, which is napisa ng puwersa and designated by F again, but this time it is called solid force or F solid. Ano ibig sabihin ng solid force? Ito yung parang yung mga massive force. Okay, so parang kung baga, parang ginaganan mo lang ng medyo mabigat na bagay itong second condition. Itong third condition naman, napakalaking timbang yung ginawa mo. That's why napipi ng sobra itong spring at yung distansya na yon ay solid height na tinatawag. If this is compressed length, actually basically compressed length is the same as the solid height. Ang pagkaiba lang, yung force kasi na nag-apply, which is F solid, is always larger than this F. That's why napipi siya ng solid height. So solid height is less than the compressed length. And syempre, kung may deformation ka dito due to F, may deformation ka rin dito due to F solid. And that was the solid deformation. Okay, so dali lang naman tandaan. Free length is equal to deformation plus compressed length. And it is also equivalent to solid deformation plus solid height. Yeah. So that was the 4 types of ends used in compression spring. We have the plane, the plane and ground, the squared and the squared and ground. At ang karaniwang sa board exam na sample is squared and ground. So that's why medyo kung may free time ka, pwede mong tandaan or reviewin itong formula, which is kailangan tandaan mo na ang number of coils, total number of coils, free length, and solid height is different from each of the four ends used in compression spring, yung drawing na ito. So we have the plane, plane and ground, squared and ground. But my tip to you guys is maybe just what you call that? Just study this number 1 and number 4 type. Pero karaniwan talagang lumalabas sa board is itong squared and ground. So meron siyang number of end coils na 3. Meron siyang total number of coils na NC plus 2. Free length niya daw is PNC or pitch times number of coils plus twice ng wire diameter. At ang solid height niya naman is wire diameter times total number of coils. And of course, we have the spring constant here. So in order for us not to memorize this one, alam natin yung formula ng deformation way back kanina. Saan ba yun? Meron. Ayan. That was 8FC cube NC over GDW. So just remember this one, and we all know basically that K is equal to force over deformation. So mag-derive mo yan. So 8FC cube NC over GDW. So cancel si F. So aangat si GDW at ang matitira is 8C cube NC sa ilalim. So just my 2 cents or tip for you not to memorize this one. Just memorize this deformation at makukuha mo na yung spring constant. Of course, we have a pitch angle way back on our first slide ng formula. And that was equivalent to arctangent of pitch over pi dm. Para lamang yung pitch angle or parang lead angle, it is the same as lead angle also. And talking about it is also equivalent to yung formula ng threaded members. Di ba? Yung lead angle natin is equal to arctangent ng pitch over pi dm. Okay, so last formula, we have may usapan namang energy kasi laging may deformation. Of course, may usapang namang energy. So in this first scenario, we have a spring under impact load. So si spring mo ay binagsakan ng weight, and of course, it has an equivalent impact load. Ibig sabihin kung 20 pounds si W, kapag bumagsak dito yan, hindi 20 pounds ang equivalent impact load mo, kundi mas malaki, no? Or ibang figure. I already discussed this on the impact load, stresses due to impact loads. Parang review na lang din to. So pakibalikan na lang yon. And of course, kung binagsakan siya, of course, meron siyang height. And syempre, andyan yung usapang potential energy. That's why W times height plus this deformed distance is equal to strain energy. So lagi mo lang siyang tatandaan that potential energy is equal to strain energy, and our strain energy is equal to 1/2 times P or the impact load times this deformation. So pangit ang box ko. Pakibura natin ang box. Yan. Okay, so in the second scenario naman, we have this weight, no? Ito kung makapansin nyo, this is a vertical scenario. This is a horizontal scenario naman for our second case, which is may weight na papunta sa kanya with certain velocity. And syempre, pag kalapag sa kanya, may impact na nag-cause ng deformation. And syempre, meron din siyang equivalent impact load. And that was equal to kinetic energy nung bagay na sasalubong sa spring, ay babangga sa spring. And it is equal to strain energy. Dito mo malalaman o ma-apply yung pinag-aaralan sa thermodynamics, no, na energy is not created nor destroyed. Lagi lamang natatransfer si energy into another form of energy. That's why if may kinetic energy ka nung hindi pa bumabangga, pagkabangga mo, may strain energy naman. And that was equal to 1/2 mv squared. We all know that KE is equal to 1/2 mv squared. But we all know that M is equal to weight over gravity. Kasi nga weight is equal to mass times gravity. So that was equal to KE is equal to 1/2 W over GB squared. And again, strain energy is equal to 1/2 times P times the deformation. So ayun, enough tayo sa formula review. So let us proceed on the problem solving. Determine daw the spring index. So number 1, the spring index of a spring setup is 4.5. So medyo bangag talaga si engineer ngayon, no? Pero tuloy natin to. So determine the stress concentration factor due to coil curvature. So the question is looking for concentration factor due to coil curvature, and that is your Kc. And in order for us to determine the amount of Kc, ang kailangan lang natin formula is Walls factor is equal to Kc times Ks. Hindi kill shot, no? Hindi siya kill shot. So that was factor for direct shear. So this is the Walls factor and this is the direct shear. So ito naman si coil curvature. And basically Kc is equal to K or Walls factor divided by Ks. And syempre si Walls factor meron siyang formula ng 4C minus 1 divided by 4C minus 4 plus 0.615 divided by C. And syempre, meron tayong given na spring index which is 4.5. Ayan, may 4.5. So that was a direct sub. So that will become 4.5 minus 1. 4.5 minus 4 plus 6.615 divided by 4.5. And our K is equal to 4 minus 1.5 answer. So that was equivalent to 1.35. But this is not the final answer yet, guys. So may K na tayo at kukunin na lang natin Ks. And we'll know that has a formula of 1 plus 1 over 2C. So parang magiging 1 plus 1 over 9 kasi 2 times 4.5 is 9. So that was, alam ko 1.11. Ayan, 1.11 yung ganito. So 1.11. So we can get the Kc. So that was 1.35095 divided by 1.111. And the answer is, so the spring index 7.5. Teka lang. 4C minus 1. 4C minus 4. 2.615 answer. So that was divided by 1 plus 1 over 2. Okay, so the answer is 1.216. Tama ba? 35095, 1.111. Okay, so the answer is 1.216. So meron ba tayong 1.216 here? So ang pinakamalapit is of course letter A. So the answer is letter A. So sa number 2 naman, determine the wire diameter given a mean diameter of 20 mm when the Bergstrasser factor of spring setup is 1.172. So the question is looking for the wire diameter given a mean diameter of 20 mm, and we all know that it has a relation based on the spring index that has a ratio of spring index or C is equal to dm over dw. So meron tayong mean diameter na 20 mm. So ang kulang na lang natin is letter C or spring index to determine this dw. And we all know na may given a Bergstrasser factor which is, we all know that KB is equal to 4C plus 2 all over 4C minus 3. So dito pa lang pwede nating ma-determine yung letter C kasi may given na Bergstrasser factor of 1.172 is equal to 4C plus 2 over 4C minus 3. So the trick here is you may use the sheep solve or pwede mo namang i-direct na 1.172 times 4c minus 3. So cross multiply is equal to 4c plus 2. So you are going to have a c of 1.172 times 4x minus 3 or c is equal to 4x plus 2 or c. So ang c natin is 8.017. So siguro ang ginamit dyan na c is 8 na sakto. So we may use din naman itong 8.017. So ayan, our dm is equal to c times dw. Pero ang hinahanap is dw. So dw is equal to dm over c. So that was 20 mm divided by 8.017. And our wire diameter is 2.49 or 2.5 mm. So reasonable naman yung value kasi maliliit talaga yung wire diameter. Kasi sa wire diameter, ayan lang siya. So mga spring, ayan. Ayan. Ayan, yan lang si wire diameter. Okay, so reasonable yung value. So the answer is 2.5. So the answer is letter B. Okay, so proceed tayo sa third question. A spring has a load of 50 pounds with a spring index of 8. If the induced stress is 90 KSI, determine the wire diameter. So kung merong induced stress na given, meron tayong formula kanina na total shear stress is equal to 8, 8 KFC, tapos kumain ka pa ng pi sa ilalim, at syempre may d squared ka, or may dessert, sabi mo ng dessert squared sa ilalim. So, meron tayong given na load of 50 pounds. So, F is equal to 50 pounds with a spring index of 8. If the induced stress is 90 KSI, the question is looking for the wire diameter. So, isa-isayin natin kung kompleto to. So, shear stress daw is 90 KSI. Sabihin na natin 90,000 PSI or 90 pounds per inches squared kasi naka-pound si force dyan. So, that was equivalent to 8 KFC. So, ang K natin, kailangan makuha muna natin. And we all know that K is wall factor. That was 4C minus 1 over 4C minus 4 to. Minus 4 plus 0.615 divided by C. So, kunin muna natin to para may maisulat tayo dito. So, that was 8. So, 4 answer minus 1. 4 answer minus 4 plus 0.615 over answer. So, that was 1.184. So, kung naririnig nyo ako kung ano yung sinasabi kong answer, kasi ang ginagawa ko sa calculator, guys, ipindot ko muna yung 8 o yung kung ano mang value ng C at magiging answer mo yun, di ba? So, pwede mo siyang i-type sa calculator mo na as answer. Okay? So, lalabas siya na answer. Pwede mo nang lagay na 4 answer minus 1, 4 answer minus 4, etc., etc. So, that was just my 2 cents or another trick in order for you na kunyari lang na malaki ang value ng C mo. So, i-answer mo muna siya din. Direct put doon sa next formula. So, okay. So, we have this K that is equivalent to 1.184. So, our force is the 50 pounds. Ayan. And yung C natin is 8. So, that was dimensionless or unitless. And pi dw squared. Ibig sabihin, we may cancel these pounds. And d squared is equal to inches squared. So, square root. Our expected answer should be in inches. So, perfect. The choices in inches. So, our wire diameter is 8 times K times 50 times 8 divide pi divide 90,000. Square root mo yung answer. So, the answer is 0.1158 inches or 0.116 inches. So the nearest answer is, of course, ayan, obviously, letter A. So the answer is letter A. Okay, so proceed tayo sa fourth question. A spring has a wire diameter of 25 mm with 12 active coils. If a load of 10 kilonewton is applied, it deflects by 75 mm. Determine the mean diameter of the spring. Take modulus rigidity as 80 gigapascal. So the question is looking for the mean diameter, pero as you notice, it has a given of deflection of 75 mm, and we all know the formula for deflection is equal to 8fc cube nc over gw. And let us enumerate one by one kung makukuha natin or possible makuha si wire diameter or rather mean diameter. So si mean diameter pala ang hinahanap, pero walang mean diameter na term dito sa formula na ito. But the good thing is we can get the dw because we all know that it has a relationship based on spring index. So spring index is equal to dm over dw. Pagkakuha ng dw, we may get this dm basta given si spring index. So let us enumerate the given. So si wire diameter is 25 mm and given na pala si wire diameter at 25 mm. And of course, the 12 active coils. Okay, meaning that was the NC. If a load of 10 kilonewton is applied, so meaning your F is matic 10 kilonewton or 10,000 newton. And it deflects by 75 mm. Determine diameter, basta ang given na modulus of rigidity is 80 gigapascals or 80,000 megapascals. 80,000 newton per square millimeter. At least, yung mga newtons natin or force ay naka-newtons lahat. And lahat ng measurement natin is naka-mm. So, walang problema mamaya sa unit analysis. So, F is given, 10,000 newtons. Si C wala, si NC ay given. Si G ay given, and si W ay given. Si deformation ay given. So, matik, ang makukuha natin sa formula na ito is letter C. Para maging tulay, makuha natin si mean diameter. So, isa-isayin natin. So, deformation is equal to 75 mm is equal to 8 times 10,000 newtons times C cube times number of coils, which is 12, divided by G, or 80,000 times wire diameter of 25 mm. Okay, so obviously, what? Cancel, ano ba mga cancel? So 80,000 newton newton per mm squared. So cancel si newton, cancel si mm, cancel si mm, mm times mm squared. So this is canceled. So expected that C is dimensionless kasi nga dm over w, cancel ang unit. So kunin natin si C, which is 75 times 80k or 80,000 times 25 divide 12 divide 8 divide 10,000. And just get the cube root. That was 5.386. And since we are looking for mean diameter is equal to the product of spring index times wire diameter. So that was 5.386 multiplied by 25 mm. So napakalaking wire diameter nito, halos po 1 inch. So the answer is 134.65 mm. So where's the nearest answer? So the answer, yeah, 134.6 ang nearest. So the answer is letter D. Okay, so kaya pa ba guys? Kaya pa. So 5 naman, sa 5. A spring has a rate of 30 kilonewtons per meter. If the wire diameter is 10 mm and the spring index is 7, determine the number of active coils. Use rigidity 80 gigapascal. So, ito may bago na namang introduce. So, a rate of 30 kilonewton meter, ibig sabihin yan yung K, no, this is equal to F or load over deformation. That's why meron siyang unit na Newton per millimeter or force divided by distance. So that was equivalent to K is equal to F over deformation. So, ginanto ko ito in order for us guys na hindi na dagdag alalahanin sa pagkakabisa ng formula because we all know that deformation is equal to 8fc cubed nc over gdw. Again, K is stands for the stiffness or spring rate. So, not just the Wahl's factor but it is also the spring rate. So, walang kamatayang spring rate. So, si force ay canceled meaning GDW mapupunta sa taas at sa ilalim matitira si HC cube NC. So that's why we don't need to formalize this one, memorize this one rather. Basta tanda mo lang yung formula ni deformation. And ayan, so GDW over HC cube NC. So the question is looking for the number of active coils which is NC. So isa-isay natin kung given lahat. Si K daw is 30 kilonewton per meter. Or pwede nating sabihin 30 Newton per mm na siya. Kasi pwede siya maging 30,000 Newton per meter at si meter is 1,000 mm. So 30,000 divided by 1,000. So that was also equivalent to 30 Newton per mm is equal to G which is 80 gigapascal or 80,000 megapascals. Kasi 1,000 kailangan mag-multiply ka ng 1,000 para ma-convert si gigapascal into megapascals because 1 gigapascal is equal to what you call that 1,000 megapascals. So, ayan, para ka lang convert ng mabilisan. So, just a little reminder. Okay, so si DW, meron ba tayong given na DW? So the wire diameter is 10 mm. HC cube NC. So ang spring index daw natin is 7, so that was C. Ayan, so number of coils. So cancel si mm na isa, cancel si Newton at may natirang mm dito, cancel dito. So everything is on perfect position. So number of coils will be unitless. So that was 80,000 times 10 divide 30 divide 8 divide 7 cube. 7 cube pala to. Kasi C cube eh. Divide 7 cube. So the answer is 9.72 coils. And the closest answer is letter B. So the answer is B, 9.72 coils. So let us proceed to the last item for this part 1 of the spring. A helical steel spring having 20 active turns of 20 mm wire diameter supports a load of 2.5 kilonewtons. So determine the maximum shearing stress if the mean diameter of the coils is 180 mm. Use G of 83 gigapascal. So the question is looking for the maximum shearing stress. So paano natin makukuha yan? So we all know that the formula for the maximum shearing stress or the total shear stress is equal to 8 kFc. Kumain ka pa ng pi sa ilalim, may dessert ka pa sa ilalim squared. And that dessert is wire diameter. So isa-isay natin kung given ito mga ito. So umpisa natin kay K, which is Wahl's factor of 4C minus 1 divided by 4C minus 4 plus 0.615 divided by C. So hanapin muna natin si spring index. So may given bang spring index? Wala. Pero we all know that It has a relationship of ratio of dm over dw. At may dm ba tayong given? So, so saan tayo pwedeng kumuha? Use G. A helical steel spring having 20 active turns of 20 mm wire diameter. So, ang given lang is wire diameter, which is 20 mm. So, 20 mm. So, determine the maximum shearing stress. So, saan natin pwedeng makuha si mean diameter? So, saan natin pwedeng makuha si mean diameter? So, mamaya, balikan muna natin. Okay, so teka lang. So, ayan, helical steel spring. Ayan pala. So, mean diameter of the coils is 180 mm. So, medyo bangag talaga si engineer, no? So, that was 180 over 20. So, that was spring index of 9. So, ito, pwede nating makuha. So, put, again, pindutin mo muna si 9. And that was your answer. And just simply recta muna sa calcu. So, that was 4 answer minus 1. Divided by 4 answer minus 4 plus 0.615 divided by 9 or answer. So, that was 1.162. So, check si K. So, ang F natin ay 2.5 kilonewton. So, gawin na natin newtons, which is 2,500 newtons. So, si C is 9. So, si DW is 20. So, everything is given. So, we may direct calculate this shearing stress. So, that was 8 KFC. 1.162 times natin sa 2,500 times natin sa 9, which is your C, divided by pi and divided by wire diameter of 20 squared. So, the answer is, so tingnan mo natin mga unit analysis niya. So, F dito is Newton. This is dimensionless. And we have this wire diameter of mm and in square mo. So, that was Newton per mm squared. So, our answer will be expected in megapascal. So, that was 8 times K times F times 9 divided by pi divided by 20 squared. So, the answer is 166.44 megapascals. So, the closest answer is, ayan, letter D. Okay, so that was the first 6 items dito sa topic ng spring. And this is the part 1. So we're going to proceed for the next video, which is the part 2, of course. And doon didiscuss natin yung mga energy. Na-discuss na natin yung formula kanina ng energy. So magsasagot na tayo ng sample problems na involve si energy. Siyempre. And pati na rin yung mga types nung end shape ng iba-ibang hugis kanina na discuss. So, ayun guys, salamat sa pakikinig and I hope may natutunan kayo at na-refresh dito sa pagsagot natin ng past board exam problems. Okay, so ayan, see you and God bless sa inyong review guys. Thank you, bye-bye.